welcome everyone to our webinar on the risks and solutions associated with coastal landfills. Today we're joined by Nick Cooper. Nick is a chartered civil engineer and a fellow of the Institution of Civil Engineers. He has over 30 years experience in coastal management, including the appraisal, design, consenting and construction of schemes to reduce risks from erosion of coastal landfill sites. Nick has also developed industry guidance on behalf of the Construction Industry Research and Information Association on management of coastal landfill and contaminated land on eroding and low-lying coastlines, and is part of a consortium working for DEFRA on a national assessment to tackle erosion and flooding of historic coastal landfill sites. As always, there will be a chance for questions at the end of Nick's presentation, so please do submit these throughout in the Q&A option at the bottom of your screen, and then I will ask them on your behalf at the end. So thank you everyone for logging in, and I will now hand over to Nick for the presentation.
Hello everyone. I'd like to start by thanking the IES for inviting me to speak on this topic today. I'm anticipating that some delegates will be coastal managers who are interested to learn more about dealing with risks from landfill and land contamination in their areas of jurisdiction at the coast, as well as some attendees being waste managers or land quality specialists who might be interested to know more about how coastal processes and erosion and flooding might affect sites or land areas that they are responsible for managing as well. And in this presentation, I'll try and give a bit of an appreciation of both sides, both perspectives. The erosion of coastal landfills is an emerging area of interest. It's one that has received quite a lot of media attention in recent years at local and national levels, as you can see from some of these headlines. There have been previous assessments by various researchers to try and gauge the scale of the problem, principally around England. Most studies have been around England, but there have also been some in Wales also. And the general consensus of those outputs is there are around about 1,000, 1,200 sites around England that could potentially be affected by erosion and sea flooding. The latest work on this topic is actually a DEFRA-led study looking at a national assessment of the risks. And although that's not in publication yet, it's not completed yet, I understand that that's kind of yielding the same sort of number of sites, so that there's pretty good consistency amongst those previous studies on the scale of the problem. The types of sites that I'm going to be talking about, which may be affected by these processes, come under various different categories. We can consider operational landfills. These are landfill sites that have environmental permits, are open, and are actively accepting wastes in the present day. Some of those landfills may actually be closed. They're still permitted, but they're undergoing some form of aftercare, and they're not actively receiving waste at the present time. And then after going through aftercare, some sites might actually be surrendered sites where the permit was formerly extant but is now being surrendered and the sites are no longer active. I think there will be relatively few of those sites, mainly because existing regulation hopefully will prevent these sorts of sites being opened in areas that are susceptible to flooding and erosion risks. But I think you will find that a lot more sites are historic coastal landfills. These are legacy sites. Many of them predate current regulation. And at many of these sites, tipping in the past was undertaken in an often unrecorded and certainly unregulated manner. And it's these sorts of sites that are often given headaches to contemporary coastal managers in the present day. We've inherited a legacy of problems from some of these historic sites. But also there are other categories that fall into this broad banner as well. There may be some sites that are formally classified as Part 2A contaminated land sites. That's Part 2A of the Environmental Protection Act 1990. So they're formal designations. Or if it's not formally classified in that manner, there are many other areas of, in inverted commas, land contamination, which arise from things like industrial legacy tipping, slag tips, and so on. And the principles that I'm going to talk about today actually can apply to any of these different categories of site. But I think you'll probably find most that you encounter are historic landfills or areas of other land contamination, probably. In dealing with sites of this nature, we're really working at the interface between two sectors. There's the waste and pollution prevention control sectors with its own legislation, guidance, and methods as well, techniques and methods. And then there's the flood and coastal erosion risk management sector, which similarly has its own legislation, guidance, and methods. So for those of you who are more commonly working in one of these sectors almost exclusively, when you come to work on one of these sites, we're inevitably at this interface between these two sectors. So there's a lot of learning that needs to be done from the other sector so that we have the full range of awareness of the legislation and techniques that are available. And it's actually for that reason that some years ago now, I was involved in a guidance document on behalf of Syria on managing sites of this nature on eroding or low-lying coastlines. And actually during this presentation, I'll be drawing from the core management framework that we developed in this guide and has served quite well to the present day. And that really focuses on these different stages. A first stage, the top box there, is essentially a sort of feasibility and desk study to identify and characterize particular sites, assess the risks that may exist. Moving on to the second stage is more of an appraisal of the options. Third stage is, once you've got a preferred option, is the work that needs to be done to deliver that solution. And then importantly, a final and important stage of the process is to evaluate the performance of your solution against the initial risks that were present, because there may still be residual risks that need to be monitored and managed in some way. So it's that sort of cycle that I'll be talking about today. Taking them step by step then, how do you go about identifying sites that are at risk from erosion or flooding? Well, if that's an immediate problem, you'll obviously see through visual inspection material that may be eroding out from your site onto the beach or into the marine environment. And that's an immediate problem that probably needs dealing with some degree of urgency. But some of your sites may be set back a little from the coast. So you can use existing techniques and tools and data sets to make projections of where the coastline may be in future epochs, such as 25, 50, 100 years, and so on, to see whether your site will, at some future point in time, become at risk from erosion. And there's a recent product from the Environment Agency called National Coastal Erosion Risk Mapping, which can provide very useful data to help you in that process. That covers England, I should say. Similarly, there are flood risk maps that are available. In England, they're called flood maps for planning on the sort of gov.uk website, but there are similar equivalents available in Wales and Scotland, which show the extent of sea flooding that would arise in the absence of any defences under a 1 in 200 year or a 1 in 1,000 year return period flood event at the site or at that particular coast. And again, you can see whether your site would fall within one of those boundaries. So it's fairly readily possible to identify whether or not your site is currently or may in the future become at risk from either erosion or sea flooding. So if your site does fall into those categories, I think the next step is to try and characterize as much as you can about its history and document its physical setting, understand its physical setting. That's done through desk study. For the site history, particularly if you're dealing with historic coastal landfills, as I mentioned, there might not be much or any data records available. And therefore, you might need a quite forensic approach, digging back through archives and documents and historic maps, plans, aerial photos, to try and build up a picture of understanding of how that particular site has developed over time, when it may have been infilled with waste, and potentially by neighbouring activities, what might that nature of that waste be. Also, in terms of the physical setting, well, contemporary data and maps help define some of the ongoing processes and geomorphological features which are prevalent at particular sites, which will again help with that context. It's important to visit sites to gain your appreciation of them in relation to the wider setting in which they're set and the particular risks that they pose. Obviously, there are health and safety issues to consider with any site visit, but they're fairly standard to deal with. And I would recommend visiting at different tidal states. Go at low tide, so you can see the wider environment, the different geomorphological features there, and also go at high tide, because then you can potentially see some of the processes that are causing erosion at the site, actually in practice. If you can't visit the site during that time because it's unsafe to do so, you can set up remote cameras and so on as well. And during this initial phase, it's often good to have a first tranche of sampling or investigation. Again, there are health and safety aspects to consider, but results from that can be quite helpful for providing a broad characterization of a site and providing some indicative idea of the risks that may be posed. The next stage of this sort of early step is to then assess the risks that that site may pose should materials be released. And we recommend using what's called the classic risk model of source of a risk, a receptor to the risk, and some pathway by which the source can come into contact with a receptor. If you work in the land quality sector, you'll be very familiar with this already. If you work in the coastal management sector, you may not be so. But if you've read any environmental impact assessment, for example, it tends to use this source pathway receptor type approach. So the principles of this are pretty well established. And I'll just go through those elements in turn. So the sources of risks at these sites, we must remember, can take different forms. We perhaps tend to think about solid form, the soils and the physical materials that we can actually visibly see. And yes, that is one form of the source of risk, but there can be liquid or gas forms as well. And of course, over time, a particular waste may decompose from one state to another as well. So the nature of the risk, the nature of the source of the risk may change over time. But there are well-established ways of monitoring, sampling, and investigating the chemical aspects of these different sources of risk at a particular site. For example, water sampling, augering, boreholes, and so on. I should say at this stage, there are some sites that require very specialist advice. And they particularly relate to sites where there may be biological or radioactive hazards. There may be the presence of asbestos, either fiber or bound form, or there are munitions and explosives. So those sorts of aspects do require specialist advice. The pathways by which a source can come into contact with a receptor, if we're using this model, are numerous, and you have to consider that at your site. You have to consider, each pathway linkage that may exist. I've just put a few schematic examples up here. An immediate case may be present at a site where the waste is relatively exposed at its coastal margin, so that if erosion occurs on that coastal face, then the waste is immediately released onto the beach or into the marine environment. Looking at a different variation on that, there might be similar sorts of sites, but where there are coastal defences in situ, and they prevent that erosion from occurring, other than at times when you get either waves overtopping the crest of the defence or surges overflowing the crest of the defence and removing the capping layer of soil and exposing the waste, or if the beach lowers and you get scour holes developing at the toe of the structure and waste can come out underneath this structure, or the structure may actually lead to eventual collapse or breaching. And of course, that leads to more waste coming out. And in some situations, there can be waste incorporated within the core of a coastal defence structure. There are many examples in Essex, for example, where waste is the core of flood embankments around various estuaries. It is sometimes used as core material in port and harbour structures I've encountered as well. And as erosion or material degradation of that outer shell occurs, then the inner core can also become exposed, releasing material into the wider environment. And finally, thinking more about longer term strategic planning issues, there can be some sites where there is a desire to remove or breach an existing sea or coastal defence so that the land behind can become flooded, for example, for creating new intertidal habitat. But there may be constraints imposed on delivering such options where there is known to be waste within the land to the rear of the existing defences. So they're the main sort of models, if you like, of pathway that we could think of. In terms of the receptors that may be affected if they come into contact with some of these materials, we obviously have humans, and there are public health and safety considerations. There's the wider environment, not only the ecology, but also the amenity and landscape. Some issues at sites can be more, shall we call it, a littering type issue, or an amenity, reducing the amenity value of an area through the pollution that is occurring, rather than being ecotoxicological, I should say. There are properties that can be affected as well, crops, for example, and controlled waters, groundwaters, rivers, seas. They could all have their water quality affected if these wastes end up in them. So in order to assess the risks, I think there are well-established risk assessment procedures that hopefully are known to you fairly thoroughly. And I don't intend to go through those in any great detail. There's lots of existing guidelines on how to go about risk assessment. But essentially, we're trying to either categorize or quantify a risk into its nature, depending on the receptors that are subject to the exposures. And that may be, right away from very high risk right away down to very low. And I think that's a very useful and important step, because it does help prioritize the management actions that may be taken at a particular site, particularly when I feel it's important that those actions are proportionate to the risk that exists. So for example, would you come up with a solution that is many tens of millions of pounds if the actual risk assessment is showing you've got a very low risk? That probably wouldn't be proportional in most people's considerations. Moving on to the second step in that flow diagram I showed you earlier is the appraisal process, the appraisal of options. And again, like risk assessment, there are very well-established processes, procedures, guidance on options appraisal. If you're a coastal manager, you'll probably be well familiar with the flood and coastal erosion risk management appraisal guidance. If you're more from the waste management side of things, you may be more familiar with the best available technique type approach, the BAT type approach. But essentially, they're similar principles. We define a problem or an issue. That source pathway receptor model helps in that process. We define the aims and objectives of a project. You may have compelling legislative drivers that really are driving your project, or you might just have organizational aspirations. You may want to sort of reduce a littering type of pollution. So that's one extreme to the other. But I think you've got to understand your drivers behind your scheme, and that's got to be informed by your risk assessment, proportional to the risks. But essentially, once you've defined that, you can establish a long list of potential options. go through some form of screening process to narrow that down to a short list. And then usually you subject a short list of options to more detailed, more robust technical, environmental, and economic assessments. And in some situations, you may also apply social, local community assessments and so on. But essentially, sustainability ought to be at the heart of all of these things. And that will lead, hopefully, to a preferred option or suite of options that, as I say, ought to be proportional to the risks that are present on your site. And the type of options really can be categorized as follows. Do nothing isn't really an option if you have identified a risk. You're kind of compelled to do at least a minimum amount of management activity, but do nothing does provide a useful economic base case for comparison against some of the other options. Do minimum, that could involve ongoing inspection, surveillance, for example, warning signs, fencing, etc. That may be okay as a short-term measure, or if your site has very low risk. But if you're at a higher risk site, or want to develop a more robust, longer-term solution, it's probably only useful as a short-term measure. So then coming back to the source pathway receptor model, we can actually remove the source of the risk entirely. That could involve the excavation and off-site removal of the material. That's quite a large scale and would usually be a very costly type of operation. So there are other methods as well. We could treat the material on site so that the most hazardous aspects are removed through one of those different processes that are listed there. Or we could actually use a wider range of more complicated techniques to treat the material off-site as well. As a coastal engineer, I have used physical treatment before, but any of those other treatments that I've listed there are well beyond my area of expertise. And so I rely on colleagues internally to provide additional advice on those areas. But they would be, I would imagine they would be very familiar to those of you that do work within the waste management sector. Another option is to break the pathway between the source and the receptor. That can be done by cleanup operations, but they're very reactive and they do rely upon a very regular regime. It's a bit pot luck as to whether you'll get there in time to clear up some waste. So it's not the best option. More robust are those options that provide some form of physical barrier, such as a cover system, a cut-off wall, or as you see pictured there, various types of coastal defense. And later on, I'll give you an example of some coastal defense option that we delivered. Alternatively, we can remove the receptor from the site. Well, can we? With humans, we can place fencing and warning signs, but signs can be ignored, fences can be stepped over, climbed over, and clearly we cannot remove the natural environment from the site. So this has very limited applicability. Moving on to the third step in that flow chart, delivering a solution once you have your preferred option from that sort of suite. Many of the considerations I've listed there will be common to any type of coastal scheme that you deliver. It's just that you particularly also need to consider the fact that you're dealing with potentially hazardous materials here. So various testing, handling, reuse, disposal considerations need to be given during your delivery of the works. There are various other aspects I've listed there as well, which may well come up during the Q&A. So I'll probably park those for now. And if any do come up, I'll be happy to address them further at that stage. And then, as I said, a very important part in the process is evaluating the performance of your solution. Is it delivering its intended aims and objectives? Is it having any unintended side effects elsewhere? Are there any residual risks that you still need to manage in different ways? And that's probably best achieved through a combination of visual inspections, surveys, sampling, leading into some form of formal evaluation and update of your initial risk assessment. So I'd like to just sort of finish my presentation with a couple of case studies they are contrasting schemes. What this one here, Trowel Quarry in South Tyneside, in the town of South Shields in South Tyneside, was actually delivered some time ago now. I was surprised when I looked at when we delivered this work. It's actually 2008. But it's a very good example of a more conventional coastal defense type solution. Trowel Quarry was a limestone quarry. Quarrying was undertaken throughout, I think, the 19th and up to the mid-20th century when quarrying stopped, and the site became infilled with waste by the municipal authority throughout the 50s, 60s, and 70s. In the mid-1980s, the infilled or partially infilled site was then capped and landscaped, and the ownership was transferred to the National Trust, who since that time have managed the area as a public amenity space and nature conservation area. This shows a LiDAR image of the site looking from sea to the land, and you can pick out certain features such as the landward rim of the quarry, the 3 remaining limestone headlands that were never originally quarried, they were left in situ, and then the infilled material inside of those forming these 2 distinct bays. And the problem at this site was that since it was infilled in the 1980s, coastal processes have continued, and the exposed coastal margin began to erode, releasing some of that infill material into the wider environment. Some of that was hazardous. There was an inspection and clear up regime, but it was recognized that that was an important short-term measure, but a more robust longer-term solution was needed at this site. So, just before then, much of the material that was being released from the ongoing erosion of the exposed coastal margin was fairly inert, like the materials that you see listed there, but some was definitely not. So there was asbestos, there were chemical compounds, heavy metals, there were diesel organics, there were hospital waste as well, including syringes. In places, it was really quite nasty material. And that was presenting human health and environmental pollution risks. So we looked at 4 different options, really. They're kind of variants on 2 principal themes: the barrier type approach, where we would build a revetment along the exposed coastal margin, or variants of the sort of remove the source type approach. So we remove a little bit of the source to have a shorter revetment on the right-hand side there, remove a little bit more of the source so we could get away with just 1 revetment on a slightly different alignment, or remove the source entirely to an off-site facility. And this is all based on prices from about 15 years ago or so when we did the works. But there's a clear disparity in cost depending on which option we looked at, ranging from about £2 million for building those revetments along the shore, up to £50 million plus for removing that waste from the entire site. And this is a challenge that I think many of you will face if you have sites of this nature. As soon as you start touching this material, thinking about off-site disposal, then the costs go into the tens of millions, depending on volume, of course, but as a general rule. Driven principally by economics and to a degree by that proportionality argument that I mentioned earlier, the preferred solution, as you may have guessed, was to build the rock revetments between these limestone headlands at this particular site. And I've got a selection of pictures now which show some of the construction process. If you're a coastal manager, you'll be familiar with these. If you're more from the waste or land quality sector, I'm hoping that you may find these of interest to understand some of the logistics and mechanisms by which a conventional coastal defence scheme will be constructed. So in this particular case, the rock was quarried in Norway. It was granite. It was loaded onto a large barge over in Norway, brought across the North Sea, and then transshipped onto a shallow draft transshipment vessel, which then came inshore. This picture's at low tide, but it came inshore at high tide to discharge its load. And then as the tide went down, that material was then rehandled using land-based plant to where it needed to go on the site. Here are some pictures of those processes. This is shunting the material off at high tide. Then at low tide, you can see the stockpiles that remained, the land-based plant rehandling that. The coastal slope itself was regraded. That's an important aspect of this scheme too. And the material that was excavated during this process was taken off site as contaminated land. So that did form an element of the cost of this scheme, but it was a relatively small volume. And then to build the rock revetment, a geotextile layer was placed. The armor stone was placed in 2 layers. And then once that was complete, the upper coastal slope was regraded to a shallower angle. It was topsoiled so that there was a capping layer above the material that was being handled, and it was seeded so it became vegetated. And that shows the scheme, or the site, I should say, before the scheme was implemented at low tide, and similarly after the scheme has been completed with the revetment and the regraded slope and the vegetated slope. And as you can see from this picture, I counted there are about a dozen people in this picture, just coincidentally. And it shows you how important, or why the local authority and the National Trust felt it was important to deliver a solution at this site. It is very well used by members of the public. And then my final section of the presentation is quite a contrasting solution. This is a more recent scheme. It's at Linemouth Bay in Northumberland. This photo was taken in 2019, and this is the state of the coastal margin at that time. I'll explain a bit more about that, but first I want to talk a little bit about the history of this site for a bit of background context. In Linemouth, there were 2 collieries, the Linemouth Colliery and the Ellington Colliery, that were operational throughout the 1900s and into the early 2000s. And spoil material from those collieries was simply tipped over the natural cliffline position. You can see a conveyor belt there. That's the means by which the tipping occurred. And there's land-based plant on the photo there as well, which was then reshaping some of the tip material on the beach. And the sort of black area is essentially a colliery spoil beach. The natural beach, the underlying sand, is well buried by the spoil. You can see it's become a blackened area by that spoil. Now, the tipping of colliery spoil itself, in and of itself, wasn't the issue here, or isn't the issue here. In fact, there are many other areas in the northeast of England where colliery spoil tipping has occurred, most notably County Durham, for example. But the problem at Linemouth was that in and amongst the colliery spoil, various other, we called them waste contraries, things that are contrary to the spoil, things like plastics, rubber tubing, rubble, glass, construction rubble, domestic refuse. Over the years, various of these contraries was also tipped in an unregulated manner in and amongst the colliery spoil. Now, oh, sorry, I should have said that the spoil tipping resulted in over 30 million tons of material being tipped onto this area. And that pushed the line of the sea further seawards. So the high water mark was moved further seawards, as effectively it's a very, very large beach replenishment scheme, but using colliery spoil rather than beach sand or cobbles. And that's important because by 2005, it had pushed the shoreline to a position where as you can see on the red line on this slide here. But in 2005, the final colliery closed for the last time. And so tipping stopped. So this beach was no longer being replenished. It started eroding in places up to 5 meters a year, and it went back to the yellow line by this year. And as that erosion has occurred, those pockets of other waste countries became exposed. And all this material was being washed into the sea and onto the beaches. So we were engaged back in 2019 to look at the management options and do a bit of a feasibility study. We did a first tranche of site investigation at this stage, and that led to a preferred option, which I'll explain in a second, but then led on to a second phase of work, which was the design and consenting phase, with a more detailed tranche of site investigation, a quantitative site risk assessment, detailed design, and all the permits, licenses, and consents, and so on. And importantly, during this phase, early contractor involvement was brought in. And this was important to me as a coastal engineer, for example. It opened my eyes to the suite of waste management approaches that were available that I wasn't previously aware of. It also helped with things like buildability, costs, logistics, and so on, as any form of ECI does. And then once we'd designed the preferred option and got the necessary consents, we went to construction early last year, and it was a 12-month program finishing early this year. And the options that we considered, coming back to this classic model, could we remove the source of material? Well, in places we could. If we did that across the whole site, it would be many, many tens of millions of pounds. We actually identified that we could treat the material on the site and remove only part of the source, the part that was polluting, and that would be a much more cost-effective approach. And that's the approach we actually adopted. But we also considered, the conventional coastal defense type solution. But I think with erosion rates of over 5 meters a year and costs in excess of 10 million, it's quite a long length compared to the trail quarry scheme I showed you. You'd really have to question the sustainability of that sort of approach. And as I mentioned previously, you can't really remove the receptor from the site. So we adopted this kind of remove a bit of the source type of approach, where we excavated the materials, both the colliery spoil and the waste countries, from the site. We used an on-site treatment plant to physically separate those two different components. We then took the waste countries, the polluting waste countries, off-site and dealt with them in accordance with waste hierarchy. And once the colliery spoil was abundantly free of those waste countries, we were able to recover it to reuse in backfilling the excavations on the site. So we largely reinstated the land profile. And here are some very quick images of that process. On the left there, you see excavation from one of the work areas we targeted. And on the right, that material is being hauled across to the on-site treatment facility. It was handpicked, went through a grizzly screen. Those processes removed the very larger items. It then was all fed through a trommel drum, which was very, very effective, as you see from these photos, in separating those countries from the residual colliery spoil. As I say, the countries were taken off site and the residual treated spoil was then used to backfill. The picture on the left shows that process nearly complete. There's just one section to the top end of the picture there that's still to be backfilled. And on the right, you'll see the design drawings. The top drawing is the original profile near vertical cliff, and then the bottom profile is the design profile with a much gentler slope. It's more stable, more resilient to erosion. It was topsoiled and grassed. So again, a bit more stability than the original coastal margin. So to conclude, that was the scheme in 2019, and in fact up to about early 2024. And with the completed works, now with the topsoil reinstated, you can see the finished product. And in fact, I went back to site just 2 weeks ago, and now that topsoiled area is very well established with natural vegetation across the site, and there's been no further erosion of the coastal margin in this treated area. So I hope that's been of interest to you. I've given you a general framework within which you can assess the risks and options at these sorts of sites, and a couple of contrasting examples of where we've been involved in solutions to manage those risks. So I'll hand over back to Amy now, and happy to run through any Q&A.
Great, thank you, Nick. That was really interesting. Looks like we do already have a couple of questions, but if it's okay, I might take host privileges and ask one of myself to start with. And obviously, if anyone has any more, please do pop them in the Q&A. You mentioned at the start that obviously there's quite a range of sectors that might be interested in coastal landfills. And you mentioned the intersection between the waste and pollution prevention sector and also the flood and coastal management sector, as well as sometimes there being a need for specialist advice. Do you have any reflections on the benefits and challenges that come along with interdisciplinary working in your experience?
Well, I think the early contractor involvement aspect would be my main recommendation. Clearly, getting a wide range of options on the table at the early part of the project helps you really truly evaluate what is and isn't possible at a particular site, rather than sort of forcing yourself down one road that you're more familiar with because you come from a particular sector, and almost being blind or not aware to the other options that might be available. So yeah, there are challenges. It's about getting the right team, isn't it? And I think on the Lymouth example, we had an absolutely excellent team. The client, ourselves, we were the consultant. We had an excellent contractor who got involved at an early stage. He got their supply chain involved at the early stage as well. So we were all very embedded in the project, its aims, its objectives, its constraints, right from the outset. And we were all working to that end. We had, while we were on site, we shared offices on site and so on. So yeah, I think that's been my main experience and my main recommendation.
Great, thank you. There's plenty more coming in. So someone's asked, what happens when land ownership is unclear for historic landfills? Does the cost of management fall under local authority responsibilities? And are there any wider government schemes running to support?
That's complicated. I'm not an expert in that particular aspect, but if I think back to the guidance, the Syria guidance document that we produced, which is a very long time ago now, so please forgive my my memory on this, but essentially there is a polluter pay type principle, but if the landowner cannot be traced, then I understand it becomes sort of an orphaned site and therefore does fall under the responsibility of those with the duty of care, which probably would be the local authority. In terms of funding routes, that funding is usually cited as one of the biggest challenges, if not the biggest challenge associated with investigating and remediating sites of this nature. I think I used the term legacy earlier, and this is what we are facing. It's an economic burden associated with a legacy from previous decades, usually activities. I'm not aware of any bespoke funding sources for coastal landfill sites. The two examples I gave you, the first example, the more conventional coastal defence scheme, was predominantly funded at the time by flood and coastal erosion risk management grant in aid, but the business case was predicated on a lot of quite interesting, let's say unconventional type approaches, because convention is normally how many properties are you protecting, or that sort of thing. So we had to think about the harm that would be caused if erosion continued and a human receptor or natural environment came into contact. And the regime, as I said, that scheme was delivered in 2008. Regime is very different now. I think it's probably more difficult to get that sort of funding, or potentially even impossible. I don't know, other people's experiences. The Linemouth scheme was different in that the local authority said, we must do something here. We will find the money. And they did it through, I understand, through central government borrowing. So yeah, but there wasn't a grant as such for that particular project, and I'm not aware of any that do currently exist. There are some from DEFRA for things like investigation of sites, but the overall pot, as I understand it, is relatively small.
Great, thank you. I think that's probably touched on a few other people's questions that I can see as well. But next we will go for, someone has asked or said really that waste reuse is obviously a challenge at these sites, and they've asked what permit or reuse mechanism was used.
Yeah, I would totally agree with whoever asked that question. I think I'm right in saying that the Trow Quarry scheme predated the most recent waste regulations. I think I might, someone may correct me if I'm wrong, but I think that may have been the case. And in any case, at that particular site, we only took a very small quantity of material off-site and handled a very small quantity of material in its totality, just where we were regrading the slope. So we accepted the cost as part of our overall scheme cost of handling and taking that off-site for disposal or treatment in accordance with the waste hierarchy. On the Linemouth scheme, that was recent years, and we had a very arduous, costly, and stressful time getting through the regulatory process. We did require, for the recovery of the treated colliery spoil and its backfilling on site, we needed something called a deposit for recovery environmental permit. I haven't touched on this, but there is a CLARE code of practice which deals with the definition of waste and the use and reuse of waste materials. We were hoping that we may be able to use that at that particular site, but we were not permitted to do so by the Environment Agency as regulators, who really, in terms of the routes that we had available, it was really only getting this deposit for recovery permit. Yeah, and that was costly and arduous, and it delayed the scheme. And of course, while the scheme was being delayed, we had 5 meters per year of erosion occurring. And I did at one point work out the quantity of material that was lost to the sea whilst we were waiting for the permit to be determined. But then the process went on even longer, and I so that became a redundant figure in a way. And I haven't done a final calc on that. But yeah, that is the biggest challenge, because with these historic sites, generally, if it's classified as an historic landfill site, if you touch any material in it, you're dealing with waste. And so you're straight away into the waste regulatory regime.
Great, thank you. So I think we probably have time for just one more. And I think what you've just said, Nick, leads quite nicely on to the next question, which is at Linemouth, and I guess more generally as well, how did you allow for future climate change in the slope reinstatement?
Well, we anticipate that the coast there, being undefended, will continue to erode. What will happen now is that as it erodes, it will be the colliery spoil, the treated colliery spoil, that is released into the wider environment, and not those polluting contraries. So it's not intended that the regraded coastal slope is there and remains there for the next, say, 100 years. It is anticipated that it is largely sacrificial, but it will only start eroding, at some future year once the tidal processes start interacting with the tow.
All we've got time for now. So thank you everyone today for logging in, and I hope you found that beneficial. If you are an IES member, don't forget to record your attendance at this webinar in the IES CPD tool, which you can do in your members area. Also, make sure you've signed up to our marine and coastal science community if you haven't already, so you can keep up to date with our work in this space and future events. And if you're not an IES member, then I hope you will consider joining us. As I said, this webinar has been recorded and it will be made available on the IES website and YouTube channel. If you're watching this as a recording, please do subscribe to the channel, like the video, and click on the bell icon to get notifications when we post new videos. And finally, thank you again to Nick, and thank you to everyone for joining us today. Hope you have a lovely rest of your day and hopefully see you at some future events as well. Thank you.
Thanks, bye.